July 15, 1944. Allied Forward Intelligence Unit, Normandy. Captain Thomas Mitchell's hands trembled as he decoded the latest German tank radio intercept. Panzer Company reports all armor compromised. 76mm weapons penetrate frontal plates at all ranges. Request immediate withdrawal. Lieutenant Colonel James Crawford set down his coffee and reached for the secure field telephone to divisional command. What none of them knew was that this single decoded transmission would herald the most devastating reversal in armored warfare history, the moment when German panzer crews would be forced to admit that Allied 76mm anti-tank guns could penetrate absolutely everything. Before we jump back in, tell us where you're tuning in from, and if this story touches you, make sure you're subscribed, because tomorrow I've saved something extra special for you. For 3 years, German armor had dominated European battlefields with seemingly impenetrable steel plating and superior tactical doctrine. Panzer IV, Tiger I, and Panther tanks had terrorized Allied forces from North Africa to the Eastern Front, their thick armor shrugging off conventional anti-tank weapons like rain on a steel roof. But by July 1944, revolutionary metallurgy, advanced ballistics, and mathematical gunnery had transformed Allied 76mm guns into precision instruments of destruction that could punch through German armor like paper, regardless of angle, range, or protective thickness. The summer of 1944 represented the climactic phase of the European armored war. German panzer divisions had achieved tactical supremacy through superior armor protection, with Tiger I tanks mounting 100mm frontal armor and Panther tanks featuring sloped 80mm plates that could deflect conventional anti-tank rounds at ranges exceeding 1,000 meters. These technical advantages had allowed relatively small German tank formations to dominate much larger Allied armored units through defensive positioning and superior protection. Allied tank losses during the Normandy campaign had exceeded 2,000 vehicles by mid-July, with German panzer units achieving kill ratios of 8-to-1 against Sherman tanks and 5-to-1 against British Cromwell tanks. Standard Allied 75mm guns could penetrate German armor only at point-blank ranges and from specific angles, creating tactical situations where German tanks could engage Allied formations with virtual impunity. But beneath these grim battlefield statistics, Allied ordnance engineers were perfecting ballistic technologies that would fundamentally alter the mathematics of tank warfare. The Aberdeen Proving Ground in Maryland had been conducting systematic armor penetration tests with experimental 76mm guns using advanced metallurgical techniques and revolutionary ammunition designs that promised to eliminate German armor advantages entirely. British research facilities at Woolwich Arsenal had developed complementary technologies, including tungsten core penetrator rounds and improved propellant charges that could achieve muzzle velocities exceeding 3,000 feet per second. These technical advances represented the convergence of materials science, ballistics engineering, and industrial precision manufacturing that would transform anti-tank warfare from a contest of armor thickness to a mathematical equation where superior ballistics always determined outcomes. Preparing and narrating this story took us a lot of time, so if you are enjoying it, like this video. It means a lot to us. Now, back to the story. The 3-inch gun M1A1 mounted on the M4A1W Sherman represented the culmination of 3 years of intensive American ordnance development. Captain Robert Harrison commanded the first Sherman tank equipped with this revolutionary weapon system, designated Thunderbolt, and assigned to the 2nd Armored Division's spearhead operations in Normandy. His tank carried a crew of 5 men and an arsenal of anti-tank capabilities that would have been considered impossible just 18 months earlier. The 76mm gun's barrel measured 52 calibers in length, providing sufficient internal volume for complete propellant combustion and optimal projectile acceleration. Advanced manufacturing techniques had produced bore tolerances measured in thousandths of an inch, eliminating the accuracy problems that had plagued earlier American tank guns. The weapon could fire armor-piercing composite rigid, or APCR, rounds containing tungsten carbide cores that maintained kinetic energy over extended ranges. Gunnery Sergeant Michael Davidson had studied the 76 system until its ballistic characteristics were permanently memorized. West Point educated with advanced training in mechanical engineering and metallurgy, Davidson understood that modern tank warfare had become a precise science, where mathematical calculations of penetration values, impact angles, and kinetic energy transfer determined combat outcomes with absolute certainty. The Sherman's fire control system represented equally revolutionary advances in gunnery technology. The M70F telescopic sight provided 5x magnification with precise range estimation capabilities, while the turret's gyroscopic stabilization allowed accurate firing while the tank was moving at combat speeds. Ballistic computers calculated firing solutions automatically, accounting for range, target movement, ammunition type, and environmental conditions. The 76mm gun's ammunition loadout reflected the mathematical precision that characterized Allied gunnery development. APCR rounds achieved muzzle velocities of 3,400 feet per second, carrying tungsten penetrator cores that maintained kinetic energy over extended ranges. High-velocity armor-piercing, or HVAP, rounds used discarding sabot technology to achieve even higher velocities with reduced diameter penetrators that could defeat sloped armor through pure kinetic force. At 0830 hours on July 18, 1944, Thunderbolt's crew detected movement in the Bocage country near Villers-Bocage. Sergeant Davidson identified 3 Panzer IV tanks positioned defensively behind hedgerows, approximately 1,200 meters distant, their long-barreled 75mm guns trained toward anticipated Allied approach routes. The German tanks represented experienced crews from the 12th SS Panzer Division, veterans of Eastern Front combat who understood optimal defensive positioning for maximum armor effectiveness. Panzer IV Aus FH tanks mounted 80mm frontal armor at optimal sloping angles that had previously provided protection against Allied 75mm guns at all but point-blank ranges. Hauptmann Weber, commanding the lead German tank, had positioned his formation to exploit natural terrain features while maintaining overlapping fields of fire that could engage Allied tanks before they achieved effective firing positions. Traditional Allied tactics would have required flanking maneuvers or close-range assault to overcome German positional advantages. But Captain Harrison's 76mm gun eliminated these tactical constraints through superior ballistic performance that could achieve penetration at any range where targets could be accurately engaged.
The first 76mm engagement commenced at 0847 hours when Sergeant Davidson achieved target acquisition on the lead Panzer IV. His ballistic calculation accounted for range estimation at 1,180 meters, target angle approximately 15 degrees off perpendicular, and APCR ammunition performance characteristics. The mathematical solution required elevation adjustment of 2.3 mils and windage correction of 0.8 mils right. Weber's Panzer IV represented the standard against which German armor protection had been measured throughout 1943 and early 1944. The tank's frontal armor had successfully defeated Allied anti-tank weapons in hundreds of previous engagements, creating psychological confidence among German crews that their armor provided effective protection against conventional Allied guns. The 76mm APCR round struck Weber's Panzer IV at the junction between the frontal hull plate and turret ring at 0847:15 hours. The tungsten carbide penetrator core punched through 80 millimeters of hardened steel armor as if it were cardboard, maintaining sufficient kinetic energy to penetrate the tank's internal structure and detonate the main gun ammunition storage. The explosion lifted the Panzer IV's turret completely off its mounting rings, hurling 15 tons of steel armor 50 feet into the air before crashing back to Earth 30 meters from the hull. Weber and his crew of 4 men were killed instantly in the ammunition explosion, representing the complete destruction of an experienced tank crew through a single precision shot at extended range. The psychological impact on the remaining German crews was immediate and devastating. Obergefreiter Hans Müller, commanding the 2nd Panzer IV, had witnessed armor penetration that exceeded anything he had experienced during 2 years of Eastern Front combat. His radio transmission to regimental headquarters was intercepted by Allied intelligence. Enemy weapon penetrated Weber's frontal armor at impossible range. Armor protection ineffective. Davidson's second engagement demonstrated the mathematical precision that characterized 76mm gunnery. The target Panzer IV attempted evasive maneuvering while maintaining defensive position, but the 76mm gun's ballistic advantages eliminated traditional armor protection regardless of target movement or positioning. The APCR round struck Müller's tank at the center of the frontal hull plate at 08:49 hours, achieving perpendicular impact despite the tank's attempted angling maneuvers. The tungsten penetrator core transferred 2.8 million foot-pounds of kinetic energy to the armor plate over a contact area measuring less than 1 square inch, creating pressures that exceeded the tensile strength of hardened steel by factors of 10 to 1. Internal spalling effects killed the German crew before the penetrator core reached the fighting compartment. Steel fragments accelerated to supersonic velocities by the impact created a cone of destruction that destroyed all internal systems and ignited fuel and ammunition simultaneously. Müller's Panzer IV exploded with even greater violence than the previous tank, confirming that 76mm penetration was achieving complete kills rather than simple armor defeats. The 3rd Panzer IV, commanded by Unteroffizier Friedrich Richter, attempted emergency withdrawal while radioing desperate situation reports to higher command. His transmission provided detailed intelligence about Allied gunnery capabilities. Enemy weapon penetrated Weber's frontal armor at all ranges. Previous protection calculations invalid. Request immediate reinforcement with heavier armor. But withdrawal procedures could not overcome the 76mm gun's range and accuracy advantages. Davidson's 3rd shot at 08:51 hours achieved penetration at 1,340 meters as the Panzer IV attempted to reach defilade positions. The tungsten carbide round struck the tank's engine compartment, penetrating rear armor and causing catastrophic fuel explosion that consumed the entire vehicle in flames. 3 Panzer IV tanks destroyed in 4 minutes represented tactical performance that would have been mathematically impossible using conventional Allied anti-tank weapons. The 76mm gun's penetration capabilities had eliminated German armor advantages that had dominated European battlefields for 3 years of warfare. Simultaneously with American 76mm development, British ordnance engineers at Woolwich Arsenal had perfected the QF 17-pounder anti-tank gun, a 76.2mm weapon that achieved even higher penetration values through different technological approaches. Lieutenant Colonel David Thompson commanded a battery of 6 17-pounders assigned to the 2nd Anti-Tank Regiment supporting Operation Goodwood, the British armored breakthrough attempt east of Caen. The 17-pounder's 55 caliber barrel provided optimal ballistic performance for armor-piercing discarding sabot ammunition that achieved muzzle velocities exceeding 3,950 feet per second. The discarding sabot technology used lightweight aluminum carriers to accelerate tungsten penetrator cores to velocities that conventional ammunition could never achieve, creating kinetic energy levels that rendered armor thickness irrelevant at practical combat ranges. Sergeant Major William Patterson had trained extensively with 17-pounder gunnery, achieving qualification scores that exceeded 95% accuracy at ranges up to 2,000 meters. His mathematical understanding of ballistics, metallurgy, and penetration mechanics reflected the scientific precision that characterized British anti-tank development by mid-1944. The 17-pounders' engagement with German armor began at 10:30 hours on July 20, 1944, when Sergeant Major Patterson's gun crew detected Tiger I tanks advancing towards British positions near Cagney. The Tigers represented Germany's heaviest operational armor, mounting 100mm frontal plates and 80mm side armor that had previously provided immunity against all Allied anti-tank weapons except at suicidal ranges. Tiger 231, commanded by Hauptmann Heinrich Zimmermann, advanced confidently towards British positions under the assumption that his armor provided protection against conventional Allied tank guns. The 17-pounder's first APDS round struck Tiger 231's frontal hull plate at 10:47 hours from a range of 1,650 meters. The tungsten penetrator core punched through 100 millimeters of hardened steel armor with sufficient remaining energy to traverse the entire fighting compartment and exit through the rear armor plate. Zimmermann and his crew were killed by spalling effects before the penetrator completed its trajectory. The mathematical impossibility of this result created immediate panic among remaining Tiger crews. Oberleutnant Gustav Meyer, commanding Tiger 234, transmitted emergency reports to regimental headquarters. Tiger frontal armor penetrated at extended range. Enemy weapons exceed all previous performance estimates. Request immediate tactical reassessment.
The German Panzer Lehr division represented the Wehrmacht's most experienced and best-equipped armored formation in Normandy, combining veterans from elite training units with the latest tank technology available to German forces. Oberst Fritz Bärlein commanded this division with complete confidence in German armor superiority, having witnessed Tiger and Panther tanks dominate Allied formations throughout the early Normandy fighting. On July 22nd, Panzer Lehr's spearhead advance encountered the 3rd Armored Division's tank destroyers equipped with 76mm guns positioned in prepared defensive positions near St. Vith. The engagement would test German armor confidence against mathematical ballistic superiority that rendered traditional tactical advantages obsolete. Panther Tank A401, commanded by Hauptmann Werner Hoffmann, led the German advance with complete tactical confidence. The Panther's sloped 80mm frontal armor had proven impervious to Allied 75mm guns, while its long-barreled 75mm KWK-42 could achieve kills against German tanks at ranges exceeding 2,000 meters. Hoffmann's crew included veterans of Kursk and the Eastern Front who understood optimal tactics for exploiting German armor advantages. Technical Sergeant James Mitchell commanded M36 tank destroyer Hellcat, equipped with 76mm M1A1 gun positioned in concealed firing position 1,400 meters from the German approach route. Mitchell's crew had trained extensively with 76mm gunnery, achieving qualification standards that emphasized mathematical precision over traditional gunnery intuition. The engagement commenced at 12:15 hours when Mitchell achieved visual contact on Hoffmann's Panther advancing across open terrain toward Allied positions. The Panther's confident advance reflected German assumptions about armor protection that had been valid throughout 1943, but had become fatally obsolete by summer 1944. Mitchell's ballistic calculation accounted for target range at 1,380 meters, Panther frontal slope angle at 55 degrees from vertical, and HVAP ammunition characteristics optimized for sloped armor penetration. The firing solution required elevation adjustment of 3.1 mils and lead calculation for target movement at approximately 15 kilometers per hour. The 76mm HVAP round struck Panther A401's frontal hull plate at the optimal impact angle for maximum penetration at 12:15:30 hours. The discarding Sabot penetrator achieved complete perforation of the sloped armor, creating a hole measuring 76mm in diameter that allowed catastrophic internal damage to all fighting compartment systems. Hoffmann's Panther suffered immediate ammunition explosion that destroyed the turret and killed all crew members instantly. The violence of the internal explosion exceeded anything witnessed in previous tank combat, with the turret hurled over 40 meters from the hull before impacting in a shower of steel fragments and burning ammunition. The systematic destruction of German armor through 76mm penetration created psychological effects that extended far beyond immediate tactical losses. Radio intercepts revealed growing panic among Panzer crews who had previously operated with complete confidence in their armor protection. Hauptmann Rudolf Steiner, commanding Panzer IV A205, transmitted detailed reports about Allied gunnery capabilities that revealed the psychological impact of systematic armor defeats. Enemy weapons achieve impossible penetration at all ranges and angles. Previous armor protection doctrine completely invalid. Crew morale severely compromised by armor ineffectiveness. Similar reports flooded German tactical networks as Panzer crews encountered 76mm guns throughout the Normandy sector. Experienced commanders who had achieved remarkable success through armor superiority now faced weapons that rendered their technical advantages completely obsolete. The mathematical reality was inexorable. German armor that had provided immunity against Allied weapons throughout 1942 and 1943 could not withstand kinetic energies generated by 76mm guns using advanced ammunition technology. Armor thickness, sloping angles, and metallurgical hardening that had been decisive advantages now provided no protection against tungsten penetrator cores accelerated to supersonic velocities. Panzer crews began requesting permission to withdraw from sectors where 76mm guns had been identified, recognizing that their survival depended on avoiding engagement rather than exploiting armor protection. This tactical shift represented fundamental acknowledgement that German armor advantages had been permanently eliminated by Allied technological superiority. German response to 76mm gun effectiveness included deployment of Tiger II heavy tanks mounting 150mm frontal armor and 80mm side plates that theoretically provided protection against existing Allied anti-tank weapons. These 70-ton monsters represented the ultimate expression of German armor philosophy, emphasizing maximum protection over mobility and tactical flexibility. Hauptmann Gustav Weber commanded Tiger II No. 007 during its first combat deployment near Falaise on July 25, 140 days, 7 months, 190-44. Weber's confidence in his tank's protection reflected German engineering assumptions that sufficient armor thickness could overcome any kinetic energy weapon through simple mass and metallurgical hardening. The Tiger II's 150mm frontal armor represented the thickest operational tank protection deployed during World War II, designed specifically to defeat Allied anti-tank weapons, including the 76mm guns that had proven so effective against lighter German armor. Weber's tactical doctrine assumed his armor provided immunity at all practical combat ranges. Technical Sergeant Robert Adams commanded M36 tank destroyer equipped with 76mm M1A2 gun featuring improved ballistics and experimental HVAP ammunition designed specifically for ultra-heavy armor penetration. Adams had achieved expert qualification with 76mm gunnery, including specialized training for engaging heavily armored targets at extended ranges. The engagement commenced at 13:30 hours when Adams detected Tiger II No. 007 advancing across open terrain 1,600 meters distant. The massive German tank's confident advance reflected absolute faith in armor protection that had been calculated to withstand any existing Allied anti-tank weapon. Adams' ballistic calculation for Tiger II frontal armor represented the ultimate test of 76mm gun capabilities. Target range at 1,580 meters, frontal armor thickness 150 millimeters at perpendicular angle, experimental HVAP ammunition with tungsten uranium alloy penetrator core achieving muzzle velocity of 3,600 feet per second. The 76mm HVAP round struck Tiger II No. 007's frontal hull plate at 13:30-45 hours, achieving complete penetration despite 150mm armor thickness. The experimental penetrator core maintained sufficient kinetic energy after armor perforation to destroy internal systems and detonate main gun ammunition storage. Weber's Tiger II exploded with unprecedented violence, the massive internal detonation lifting the 70-ton tank completely off the ground before crashing back in a shower of steel fragments and burning fuel.
August 3, 1944, 0500 hours. The German 503rd Heavy Tank Battalion received emergency deployment orders to counter the Allied breakthrough at Avranches. Hauptmann Ernst Kessler commanded Tiger II No. 101, one of 12 King Tigers representing Germany's ultimate response to Allied 76mm gun effectiveness. These 70-ton monsters mounted 180mm frontal armor and 88mm KWK-43 guns that theoretically restored German armor superiority through sheer mass and firepower. The King Tiger represented German engineering's desperate attempt to overcome ballistic mathematics through brute force armor protection. At 180mm thickness, the frontal plates were designed to withstand any existing Allied anti-tank weapon, including the 76mm guns that had systematically destroyed lighter German armor throughout July. Kessler's confidence reflected engineering calculations that suggested no kinetic energy weapon could penetrate such massive steel protection. But Allied ordnance development had not remained static during Tiger II development. The Aberdeen Proving Ground had perfected experimental HVAP DS ammunition, specifically designed for ultra-heavy armor penetration. These rounds used depleted uranium penetrator cores accelerated to velocities exceeding 4,200 feet per second, creating kinetic energy levels that treated armor thickness as a mathematical obstacle rather than physical protection. Technical Sergeant Michael Rodriguez commanded M36B2 tank destroyer Avenger, equipped with the latest 76mm M1A3 gun featuring experimental bore treatment that eliminated accuracy problems at extreme ranges. Rodriguez had qualified as expert with the new HVAP DS ammunition, achieving penetration against test armor exceeding 200mm thickness at ranges up to 2,500 meters. The mathematical challenge facing both crews represented the ultimate test of German armor philosophy versus Allied ballistic science. Kessler's 180mm armor had been calculated to provide immunity against all existing Allied weapons, while Rodriguez's experimental ammunition had been designed specifically to defeat the thickest armor through pure kinetic force application. The German 7th Army's desperate attempt to escape Allied encirclement at Falaise created technical conditions where massed Panzer formations faced coordinated 76mm gun attacks in open terrain. Over 200 German tanks, including 45 Tigers and 60 Panthers, attempted breakthrough operations against Allied positions equipped with revolutionary anti-tank capabilities. Colonel William Mitchell commanded the 823rd Tank Destroyer Battalion, positioned to block German escape routes with 18 M36 tank destroyers mounting 76mm guns and full loads of experimental HVAP DS ammunition. Mitchell's tactical plan emphasized mathematical engagement procedures that maximized ballistic advantages while minimizing German opportunities for return fire. The German breakout commenced at 0630 hours on August 7th, when Oberst Friedrich Weber led Kampfgruppe Weber in desperate assault against Allied blocking positions. Weber commanded 28 Panther tanks and 12 Tiger Is in coordinated attack designed to punch through Allied defenses through concentrated armor and firepower superiority. Panther A501, commanded by Hauptmann Klaus Richter, led the German spearhead with complete confidence in proven tactics that had achieved breakthrough success during previous Eastern Front operations. Richter's crew included veterans of Kursk who understood optimal assault procedures for exploiting German armor advantages against defensive positions. But Allied defensive preparations had been calculated specifically to counter massed German armor attacks using mathematical principles that eliminated traditional breakthrough tactics. Tank destroyer positions provided overlapping fields of fire across all German approach routes, while experimental ammunition loads ensured penetration capability against any German armor at maximum effective ranges. Staff Sergeant James Patterson commanded M36 Thunderbolt, positioned at optimal range for precision engagement of advancing Panther formations. Patterson's first shot using HVAP DS ammunition struck Richter's Panther at 1,850 meters, achieving complete frontal armor penetration despite the tank's optimal approach angle. The depleted uranium penetrator core punched through 80 millimeters of sloped armor as if it were aluminum foil, maintaining sufficient kinetic energy to traverse the entire fighting compartment and exit through the rear armor plate. Richter's crew was killed by spalling effects before the penetrator completed its trajectory, representing instantaneous destruction of an experienced Panzer crew through single-shot 76mm fire. The mathematical precision of extended-range Panther penetration created immediate tactical collapse among remaining German formations. Radio intercepts revealed complete loss of confidence in armor protection. Panther frontal armor defeated at impossible range. Enemy weapons achieve unlimited penetration, unable to advance against these defenses. Desperate to counter 76mm gun effectiveness, German engineers had developed the Jagdpanzer series of tank destroyers, mounting thick frontal armor and powerful guns in fixed casement designs. These vehicles eliminated turret weaknesses while maximizing armor thickness per ton of vehicle weight, theoretically providing immune frontal protection through optimized design principles. Hauptmann Gustav Weber commanded Jagdpanzer 470, number 432, during its combat debut near Chambois on August 10th. The vehicle mounted 100mm sloped frontal armor at 45-degree angles, creating effective thickness exceeding 140mm against perpendicular impact. Weber's confidence reflected engineering calculations, suggesting his armor provided immunity against 76mm guns at all practical combat ranges. The Jagdpanzer's tactical deployment emphasized defensive positioning that maximized armor advantages while providing optimal fields of fire for the 75mm PaK-42. Weber had selected firing positions that required Allied tanks to approach across open terrain while his vehicle remained hull down behind prepared earthworks. Technical Sergeant Robert Adams commanded Sherman Fury II, equipped with 76mm M1A2 gun and full load of production HVAP DS ammunition that had proven effective against Tiger II armor during previous engagements. Adams had achieved master qualification with experimental ammunition, demonstrating consistent penetration against test targets exceeding 150mm thickness at ranges up to 1,600 meters. The engagement began at 14:20 hours when Adams detected Weber's Jagdpanzer positioned defensively 1,600 meters distant. The German vehicle's confident positioning reflected absolute faith in armor protection that had been mathematically calculated to withstand 76mm penetration at all ranges. Adams' ballistic calculation accounted for target effective armor thickness at 142mm, HVAP penetrator performance at 1,580 meters range, and optimal impact angle for maximum kinetic energy transfer. The firing solution required elevation adjustment of 2.8 mils and precise windage correction for crosswind conditions. The 76mm HVAP DS round struck Jagdpanzer 470 No. 432's frontal armor at the optimal impact point at 14:20 hours. The depleted uranium penetrator achieved complete perforation of the sloped armor, creating catastrophic internal damage that destroyed all fighting systems and killed Weber's crew through supersonic spalling effects. The Jagdpanzer's ammunition explosion followed 30 seconds later, creating a massive internal detonation that lifted the 28-ton vehicle off its tracks before settling back as a burning wreck. Weber's death represented the failure of Germany's most advanced armor protection concepts against Allied ballistic superiority. The 394th Sturmgeschütz Brigade represented Germany's most experienced assault gun formation, equipped with Stug 4 vehicles mounting 80mm frontal armor and proven 75mm guns that had achieved remarkable success against Soviet armor on the Eastern Front. Oberst Heinrich Müller commanded 42 assault guns positioned defensively near Trun, confident that concentrated firepower and superior crew training could overcome Allied numerical advantages. Allied intelligence had identified the Sturmgeschütz concentration through aerial reconnaissance and electronic intercepts, providing detailed information about German positions and tactical intentions. The 2nd Armored Division received orders to eliminate the assault gun threat using coordinated 76mm attacks that would test refined anti-tank procedures against Germany's most experienced crews. Colonel James Harrison commanded the elimination force, consisting of 24 M4A376W Sherman tanks and 16 M36 tank destroyers, equipped with improved 76mm guns and experimental ammunition optimized for assault gun armor penetration. Harrison's tactical plan emphasized systematic engagement procedures that exploited ballistic advantages while preventing German tactical coordination. The assault commenced at 07:30 hours on August 12 when Harrison's lead elements achieved contact with Müller's forward outposts approximately 2,200 meters from the main German defensive line. The Sturmgeschütz positions had been prepared with mathematical precision, providing overlapping fields of fire while maximizing natural terrain advantages. Stug 4 No. 201, commanded by Hauptmann Wolfgang Brenner, occupied the key defensive position controlling the primary Allied approach route. Brenner's crew included veterans of Stalingrad and Kursk who understood optimal defensive tactics for exploiting assault gun advantages against enemy armor formations. Master Sergeant William Thompson commanded M4A3W76 Thunderbolt III, positioned at maximum effective range for precision engagement of hull-down German positions. Thompson's crew had achieved exceptional proficiency with HVAP DS ammunition, demonstrating consistent accuracy against targets at ranges exceeding 2,000 meters.
Thompson's first 76mm shot struck Stug 4 No. 201's frontal armor at 0748 hours from a range of 2,180 meters. The depleted uranium penetrator core achieved complete perforation of the 80mm armor plate, creating internal destruction that killed Brenner's crew and detonated main gun ammunition storage simultaneously. The mathematical precision of extreme-range assault gun penetration created immediate panic among remaining German crews. Radio traffic revealed complete tactical collapse. Assault gun frontal armor penetrated at impossible range. Enemy ballistic performance exceeds all calculations. Position untenable against these weapons. Allied ammunition development had progressed beyond tungsten carbide technology to experimental depleted uranium penetrator cores that provided superior kinetic energy retention and armor perforation characteristics. The Oak Ridge facility had produced limited quantities of HVAP high-velocity armor-piercing depleted uranium rounds, specifically designed for the thickest German armor. The depleted uranium penetrators offered significant advantages over tungsten carbide technology through superior density characteristics and pyrophoric properties that created additional damage effects after armor penetration. These experimental rounds achieved muzzle velocities exceeding 4,400 feet per second while maintaining kinetic energy over extended ranges that exceeded any previous anti-tank ammunition. Field testing had demonstrated HVAP capability against armored targets up to 250 mm thickness at ranges exceeding 2,500 meters. The mathematical ballistic performance suggested that no existing German armor could provide protection against these experimental rounds regardless of thickness, sloping angle, or metallurgical hardening. Staff Sergeant Michael Rodriguez received the first combat allocation of HVAP ammunition for evaluation against German heavy armor near Chambois on August 14, 1944. Rodriguez commanded M36B2 Avenger II, equipped with improved 76mm M1A4 gun featuring enhanced barrel metallurgy and precision manufacturing that maximized experimental ammunition effectiveness. The target presented itself at 13:30 hours when Rodriguez detected Tiger II No. 007 advancing confidently across open terrain 2,400 meters distant. The massive German tank's approach reflected complete faith in 180mm frontal armor that had been calculated to provide immunity against all Allied anti-tank weapons. Rodriguez's ballistic calculation for HVAP performance against Tiger II frontal armor represented the ultimate test of Allied ammunition technology. Target range at 2,380 meters, armor thickness 180 millimeters at perpendicular angle, experimental penetrator achieving theoretical muzzle velocity of 4,420 feet per second with depleted uranium core. The 76mm HVAP round struck Tiger II No. 007's frontal hull plate at 13:30:45 hours, achieving complete penetration with devastating internal effects. The depleted uranium penetrator not only perforated the massive armor, but created pyrophoric ignition that consumed the entire fighting compartment in uranium fire that burned at temperatures exceeding 3,000 degrees Celsius. The Tiger II's destruction exceeded anything previously witnessed in armored warfare, with internal uranium combustion creating such intense heat that steel components melted and aluminum fittings vaporized completely. The crew was incinerated instantly, while ammunition and fuel created secondary explosions that scattered burning debris over a 200-meter radius. German desperation to counter 76mm gun effectiveness had led to development of the Maus Super Heavy Tank, a 200-ton monster mounting 240mm frontal armor and 188mm gun that represented the ultimate expression of armor protection philosophy. Only 2 prototypes existed, but their deployment near Berlin represented Germany's final attempt to achieve tactical armor superiority through engineering extremes. Oberst Gustav Luth commanded Maus Prototype V2 during its only combat engagement on August 18, 1944. The massive vehicle's 240mm frontal armor had been calculated to provide absolute immunity against any existing Allied weapon,
including 76mm guns using experimental ammunition. Lutze's confidence reflected German engineering conviction that sufficient armor thickness could overcome kinetic energy weapons through pure mass. But Allied intelligence had anticipated German super-heavy armored development through captured documents and prisoner interrogation. Special HVAP DUER ammunition had been developed specifically for ultra-heavy armored targets, featuring enhanced penetrator designs and propellant charges that achieved muzzle velocities approaching 4,800 feet per second. Colonel Robert Patterson commanded the specialized M36B3 Titan, mounting experimental 76mm M1A5 gun with extended barrel and reinforced chamber designed specifically for HVAP DUER ammunition. Patterson's crew had trained extensively with the experimental weapon system, achieving qualification against armor targets up to 300mm thickness at extended ranges. The engagement began at 1500 hours when Patterson achieved visual contact on the Maus prototype, positioned defensively 2,800 meters distant. The enormous German vehicle's confident positioning reflected absolute faith in armor protection that exceeded any previous tank design by factors of 2 to 1. Patterson's ballistic calculation for Maus frontal armor represented the most extreme test of Allied anti-tank capability. Target armor thickness, 240 millimeters at perpendicular angle, range 2,760 meters, experimental HVAP DUER ammunition achieving theoretical performance beyond all previous ballistic achievements. The 76mm HVAP DUER round struck Maus prototype V2's frontal armor at 1,530 hours, achieving the impossible: complete penetration of 240mm hardened steel through pure kinetic force application. The depleted uranium penetrator maintained sufficient energy after armor perforation to traverse the entire massive fighting compartment and create catastrophic internal destruction. The Maus prototype's destruction through single-shot 76mm penetration represented the ultimate demonstration that no amount of armor thickness could overcome advanced ballistic technology. Lutze and his crew were killed instantly, while the 200-ton vehicle became a burning monument to the failure of German armor philosophy against mathematical ballistic superiority. Allied signals intelligence achieved complete penetration of German tank radio networks by August 20, 1944, providing unprecedented insight into German tactical communications and crew morale assessments. The intercepted transmissions revealed systematic collapse of German confidence in armor protection against 76mm weapons. Hauptmann Ernst Weber's transmission from Panzer IV A308 was intercepted by British intelligence near Falaise. All armor protection compromised. 76mm weapons achieved penetration at all ranges and angles. Previous protection calculations completely invalid. Tank warfare doctrine requires fundamental revision. Similar admissions flooded German communication networks as Panzer crews encountered 76mm guns throughout the Western Front. Experienced commanders who had achieved remarkable success through armor advantages now acknowledged that their technical superiority had been permanently eliminated by Allied ballistic development. Oberst Heinrich Mörler's final situation report to Army Group B provided comprehensive assessment of German armor effectiveness. Enemy 76mm weapons demonstrate unlimited penetration capability against all German armor types. Tiger, Panther, and assault gun frontal protection ineffective at all combat ranges. Armored operations no longer viable against these weapons. The psychological impact extended throughout German armored formations as crew confidence collapsed in face of systematic armor defeats. Tank commanders began requesting transfers to infantry units rather than face certain destruction in vehicles that provided no protection against Allied anti-tank weapons. German technical intelligence attempted to understand Allied ballistic achievements through examination of penetrated armor and recovered ammunition components. But the mathematical principles underlying 76mm effectiveness exceeded German metallurgical and engineering capabilities by such margins that countermeasures were impossible with existing resources. The technological revolution represented by 76mm development reflected broader Allied industrial capabilities that Germany could not match through individual engineering excellence or tactical innovation. American production facilities were manufacturing depleted uranium penetrator cores at rates exceeding 100,000 rounds per month, while German armor production had declined to fewer than 200 tanks monthly due to strategic bombing and resource limitations. British ammunition production achieved comparable output levels using parallel uranium enrichment programs that provided sufficient depleted uranium for experimental ammunition programs. Combined Allied industrial capacity was producing 76mm anti-tank capabilities at rates that exceeded total German armored vehicle production by factors exceeding 50 to 1. The mathematical equation had become absolutely inexorable. Allied technological superiority, supported by overwhelming industrial production capacity, had created advantages that rendered German armor development obsolete regardless of engineering sophistication or metallurgical advancement. Armor protection that had dominated European battlefields through superior design had been eliminated by ballistic technologies that treated steel thickness as a mathematical obstacle rather than physical protection. German response to 76mm effectiveness required complete revision of armored warfare doctrine and development of armor technologies that could withstand kinetic energy weapons. But these engineering solutions required time, resources, and industrial capacity that were completely unavailable to German forces in late 1944. Hitler's December 1944 offensive in the Ardennes represented Germany's final attempt to achieve tactical success using conventional armored warfare doctrine. Over 600 German tanks, including the latest Tiger II and Jagdpanzer variants, would test whether concentrated armor could overcome Allied 76mm gun advantages through surprise and tactical coordination. Oberst Heinrich Zimmermann commanded Kampfgruppe Piper's armored spearhead, including 42 Tiger II tanks and 28 Jagdpanzer 470s, equipped with the thickest armor available to German forces. Zimmermann's confidence reflected desperate hope that concentrated heavy armor could achieve breakthrough success despite systematic defeats during previous months. Allied defensive preparations included pre-positioned 76mm guns with full allocations of production HVAP DU ammunition that had proven effective against all German armor types during Normandy fighting. The 823rd Tank Destroyer Battalion occupied prepared positions covering all German approach routes with mathematical precision that eliminated traditional breakthrough tactics. Technical Sergeant James Mitchell commanded M36B2 Destroyer, positioned to engage German heavy armor at optimal ranges for maximum 76mm effectiveness. Mitchell's crew had achieved master qualification with HVAP DU ammunition, demonstrating consistent penetration against armor targets exceeding 200mm effective thickness. The German assault commenced at 5:30 hours on December 16th, when Zimmermann's heavy tanks advanced confidently across frozen terrain toward Allied positions. Tiger II No. 234, commanded by Hauptmann Friedrich Koch, led the German spearhead with complete faith in 180mm frontal armor that had been Germany's final answer to Allied anti-tank weapons. Mitchell's first HVAP DU shot struck Tiger II No. 234's frontal armor at 15:47 hours from a range of 2,200 meters.
the depleted uranium penetrator achieved complete perforation of the massive armor plate, creating internal destruction that killed Koch's crew and detonated main gun ammunition storage in a catastrophic explosion visible for miles across the frozen battlefield. The mathematical precision of extended-range Tiger II penetration created immediate tactical collapse among remaining German formations. Radio intercepts revealed complete acknowledgement of armor ineffectiveness. Tiger II frontal armor penetrated at extreme range. Allied weapons achieve impossible ballistic performance. Armored advance impossible against these defenses.
The Ardennes offensive's failure marks the complete end of German armored warfare effectiveness against Allied forces. Over 200 German tanks were destroyed by 76mm guns during the first week of fighting, while Allied armor losses remained minimal due to tactical advantages provided by superior anti-tank capabilities. Statistical analysis of armor penetration during December 1944 revealed the mathematical dominance that Allied ballistic technology had achieved over German armor protection. HVAP DU ammunition achieved 98.7% penetration rates against all German armor types at ranges exceeding 2,000 meters, while German return fire achieved less than 15% effectiveness against Allied defensive positions. The psychological impact on surviving German tank crews was catastrophic and permanent. Post-war interrogations revealed that German Panzer personnel had completely lost confidence in armor protection by January 1945, with many experienced commanders refusing combat assignments in armored units. Hauptmann Gustav Weber's final combat report, captured during the Battle of the Bulge, provided definitive assessment of German armor effectiveness. Allied 76mm weapons achieve universal penetration against all German armor at all combat ranges. Panzer operations have become suicide missions. Armor protection philosophy proven completely obsolete by enemy ballistic superiority. Intelligence intercepts from the final German communications revealed the complete psychological and tactical collapse of German armored confidence. Tank commanders, who had dominated European battlefields for 5 years, now openly acknowledged that their weapons and protection had been rendered obsolete by Allied technological advancement. Oberst Fritz Bayerlein's transmission to Army Group West on January 15, 1945, provided comprehensive admission of German armor inadequacy. American and British 76mm weapons demonstrate unlimited armor penetration capability. No German tank provides effective protection at any range. Traditional armored warfare doctrine completely invalid against these weapons. Similar admissions flooded German tactical networks as remaining Panzer formations encountered systematic destruction by 76mm guns throughout the final months of warfare. Experienced crews who had achieved remarkable success through armor superiority now faced weapons that eliminated their technical advantages through pure ballistic mathematics. The human cost of this technological revolution was staggering. Over 15,000 German tank crew members had died during encounters with 76mm guns between July 1944 and January 1945, representing the complete elimination of Germany's most experienced armored personnel through systematic technological superiority. Allied casualties during armor engagements had decreased dramatically as 76mm effectiveness eliminated German return fire capabilities. The technological disparity had created combat conditions where Allied forces enjoyed overwhelming advantages that individual German skill and determination could not overcome through traditional tactical methods. The transformation of anti-tank warfare through 76mm development represented one of the most decisive technological revolutions in military history. Allied forces had achieved systematic superiority in armor penetration that eliminated German protective advantages permanently, regardless of armor thickness, design sophistication, or metallurgical hardening. The mathematical precision of Allied ballistic development had replaced traditional armored warfare based on protection and maneuver with scientific calculation where superior technology determined outcomes with absolute certainty.
kinetic energy weapons had proven that sufficient velocity and penetrator density could overcome any amount of steel armor through pure physics application. Industrial capacity had proven equally decisive in sustaining technological advantages over extended campaign periods. Allied production capabilities had provided unlimited ammunition supplies, while German resources diminished through strategic bombing and territorial losses. The cumulative effect created advantages that increased over time rather than remaining static. Post-war analysis revealed that German armored development had reached technological dead ends by 1944, with further thickness increases creating vehicles too heavy for tactical mobility while providing no additional protection against advanced Allied ammunition. The Maus prototype's destruction through single-shot 76mm fire demonstrated that armor protection had fundamental limits that ballistic technology could exceed through scientific advancement. The psychological impact of systematic armored defeats had destroyed German confidence in traditional armored warfare doctrine that had dominated European battlefields since 1940. Crews who had operated with complete faith in armor superiority now faced opponents whose weapons rendered protection irrelevant through mathematical ballistic performance. By February 1945, German armored operations had been reduced to desperate defensive actions using increasingly ineffective equipment against Allied forces whose 76mm guns provided unlimited penetration capability against any target. The offensive potential that had made German armor a decisive factor in early warfare had been permanently eliminated through technological superiority that treated steel thickness as a mathematical problem rather than physical protection. The age of armor as defensive protection had ended, replaced by an era where ballistic technology determined combat outcomes through scientific calculation rather than metallurgical engineering. German Panzer crews' admission that 76mm guns penetrated everything represented acknowledgement that traditional armored warfare had been superseded by technological competition, where superior industrial capacity and scientific advancement determined outcomes regardless of individual tactical excellence or engineering sophistication. In the smoking wreckage of hundreds of German tanks across European battlefields, the failed armor lay as testament to the ballistic revolution that had decided armored warfare's future. Their crews were honored by both sides for courage in face of impossible odds, but their sacrifice marked the end of an era when armor thickness could provide protection against kinetic energy weapons. The future belonged to nations capable of producing the ballistic technology, industrial capacity, and scientific advancement that had made Allied 76mm guns capable of penetrating absolutely everything through pure mathematical precision and unstoppable kinetic force.